Bright Tuty. Every student matters.
So now we'll be taking up a new topic, and that new topic will be taking up the power of lenses. All the lenses, whether it is a convex lens or a concave lens, we see that they have the ability to bend the light rays either towards the principal axis or away from it, on behalf of which we call them either converging lenses or diverging lenses. Now, what exactly is meant by the power of a lens? The power of a lens means the ability of a lens to bend the light rays passing through it. Fine. So, the power of a lens is the ability or the capability. The more is the power of the lens, the more light ray will bend when it passes through that particular lens. It will be converged or diverged, that depend upon the convex lens or concave lens. Fine. Now, this power of a lens, we represent it with capital P, and it is calculated with this formula 1 upon F. F, we know it is the focal length, and the focal length should be in meters. If it is given in centimeters, then in that case we have to first of all convert it into meters. Fine. So, power is the reciprocal of the focal length. If the focal length of the lens is less, its power will be more. If the focal length is more, its power will be less. This power is represented with an SI unit. So, SI unit of power is diopters, which is represented by capital D. Fine. So, now you need to remember, very important, we knew that we had a convex lens, we had a concave lens. The focal length of a convex lens was always positive. Therefore, the power will also be positive for a convex lens, or vice versa. Means if the power of a lens is positive, we will interpret that it is a convex lens. The concave lens has a negative focal length. Why? Because the focus was in front of the lens, right? So, therefore, the power of a concave lens will also be negative. Got it? I repeat, if the power of a lens is positive, then we'll assume that the nature of the lens is that of convex lens or it is a converging lens. And if the power of the lens is coming out to be in minus, negative, we'll assume that it is a concave lens, that is a diverging lens. Fine. This we need to remember. Got it? Next, we are given a few questions based on this. Let us see. A lens has a power of minus 2.5 diopters. Right? This minus sign in itself, what does it indicate? That it is a concave lens. We will always be asked in the question, what is the nature of the lens? So, it is a concave lens or a diverging lens. We need to specify both the words, concave also and diverging also. Fine, because when we talk about the nature, we are talking about divergence or convergence ability, and we will specify also along with it that it is a concave lens. Now, what is the focal length? We know that the power is given out to be minus 2.5 diopters, and since power is 1 upon focal length, so therefore, I will say that focal length is equal to 1 upon power. Putting the value simply in this particular formula, I will get the focal length is equal to 1 upon minus 2.5 diopters. Removing this decimal, I will get 10 over here. So, focal length comes out to be, this is 2, this is 5, means 0.4. Now, this is to be remembered that since the power was in diopters, our focal length will come in meters. So, the focal length of this particular lens is 0.4 meters, or we can say that it comes out to be 40 centimeters, converting meter into centimeter by multiplying it with 100. Fine. So the focal length of this lens is 40 centimeters. This minus sign simply indicates that it is a concave lens, or the focus is formed in front of the lens. Fine. Let us see another question of it. Now, what is given in the question is a convex lens of focal length 25 centimeters. Given to us is focal length of the lens small f is equal to 25 centimeters, and since it is a convex lens, the focal length will be taken as positive. And a concave lens of focal length 10 centimeters. This was the first lens. There is also another lens whose focal length is also given to us. Let us take it to be f2. This is given to be 10 centimeters and this is a concave lens, so focal length will be in minus. Now students, whenever we are given two or more than two lenses, then when we place these two lenses in close contact with each other, the power of first lens assumably to be P1, the power of second lens P2, and so on, we can take the power to be of the third lens to be P3. When these lenses are placed in contact with each other, then the total power represented by capital letter P, this will be equal to the sum of the individual powers of all the lenses placed in contact with each other. So this will be the combined power. Fine. Alright. So in this particular question, we are just being said that there are two lenses. One is convex, one is concave. The focal length of both are given to us. They are placed in close contact with each other. What is the power of this combination? The power of the combination P will be equal to the sum of the individual powers of these lenses. So first of all, I need to calculate the power of the first lens. Secondly, I need to calculate the power of the second lens. Fine. And the focal length is given, so it is comparatively easier for me. I know power is given by the formula 1 upon f. So if I am calculating the power of the first lens, it should be the reciprocal of focal length of first lens and the power of second lens. Similarly, the focal length of the second lens, but in meters. This is something which you need to remember, but we are given over here, it is in centimeters. So we'll just convert them into meters. How? Dividing it by 100 simply. So first of all, I'll calculate the power of first lens. Power of first lens is 1 upon f1 in meters, which was given to be in centimeters. So this comes out to be 100 upon f1. Now it is in centimeters. That can be done. Right? Fine. So power of first lens will be equal to 100 upon 25, which comes out to be 4 diopters with a plus sign. Right? Then I'll calculate the power of the second lens. Power of second lens will be equal to 1 upon f2 in meters, or in meters, if I am calculating, dividing it by 100, I'll simply write 100 upon f2. The focal length of the second length was 10 centimeters. So the power will be equal to 100 upon minus 10. The minus sign was given, so this comes out to be minus 10 diopters because it is a concave lens. Now the total power will be the sum total of the individual powers. The first lens power was given to be plus 4 diopters and the second lens is minus 10 diopters. The combination comes out to be minus 6 diopters. So what I'll conclude from here is, when these two lenses are kept close to each other, the power of the combination will be minus 6 diopters, and the minus sign indicates that in combination it will act as a concave lens. Right? So this was the first part that we were asked, the power of this combination. Now, second part says, what is the focal length of this combination? Since we know that focal length and power are reciprocal to each other, the combined power we know, we can simply find the focal length. F will be equal to 1 upon P, F will be equal to 1 upon minus 6. Got it? Fine. Now, this F, that whatever we are calculating, it is in meters. Fine, because the power was in diopter. So, we can easily convert it into centimeters. How? Minus 1 upon 6 multiply by 100. Then it will become centimeters. Now, we can check out. It is minus 16.66 centimeters. This will be the focal length of this combination. Now, let us come to the third part of the question. Is this combination converging or diverging? Since the power of the combination is in minus, the focal length of the combination, of course, will be in minus. That means it will be a diverging lens. Got it? How it came? Fine. So, this is how we calculate the combination of lenses, total power and total focal length. Fine. Let us take one more question. This is a good question. Try to relate it. The concepts are same. The power of a combination of two lenses X and Y is 5 diopters. Now, in this question, we are given 5 diopters, which is the combination power of X and Y. That means total P we are given. Fine. And we know that total power is equal to P1 plus P2, the combination, separation of the individual powers. Now, if the focal length of the lens X be 15 centimeters, right? So, we assume that the power of X be P1 and the power of Y is P2. Focal length of X will be F1, focal length of Y will be F2. So, focal length of X, that is given out to be 15 centimeters. Calculate the focal length of the lens Y and state the nature of lens Y. Now, try to relate. I am being given the focal length of the first lens. By this, we can easily calculate the power of the first lens. Right? Let us calculate. We know that P1 will be equal to 1 upon F1, which should be in meters. But since it is in centimeters, I need to divide it by 100 to convert it into meters. So, now the power becomes 100 upon 15. Right? Fine. This is given us to be positive. So, the power of this will come out to be, we'll just simply calculate 20 upon 3 or 6.66 diopters in positive. Got it? This is the power of first lens. Got it? Now, total power is equal to P1 plus P2. Total power was given to be plus 5 diopters. P1 we have just calculated above plus 6.66 diopters should be plus P2, they should be equal. Now, putting P2 over here, we'll just shift it over plus 5 diopters minus 6.66 diopters. So, the power of second lens comes out to be minus 1.66 diopters. Right? This is the power of the second lens, which is coming out to be in minus. That means it is a concave lens. Right? The next part we were asked was, what will be the focal length of the second lens Y? So, we know that P2 will be equal to 1 upon F2 because power is the reciprocal of focal length in meters. Therefore, F2 will be equal to 1 upon P2. So, putting the value of P2, I'll get P2 was minus 1.66. So, F2 will be equal to, replacing the decimal, minus 166. Right? Fine. So, this will be in meters because the focal length is given in meters when the power was in diopter. So this is the focal length of the second lens, and because it is in minus, therefore we conclude that it is a concave lens. That means it is a diverging lens. Fine. Let us go back to the question. What was being asked? The power of combination of two lenses is given to be 5 diopters. This was total P given. The focal length of X was 15 centimeter. F1 was given, because of which we were able to find P1. We needed to calculate the focal length of the lens Y, that is F2. For that, we first of all found out P2. How? With this formula P is equal to P1 plus P2, right? Focal length of first was X lens was given, we found out P1. Then we kept this formula P is equal to P1 plus P2. We have got P1, P was given in the question, we got P2. P2 once we got, then based on the formula power is the reciprocal, we'll get the focal length of lens Y. And the nature of lens F2, that is the focal length came out to be in minus, therefore the nature of lens is diverging, it is a concave lens. Fine. So these are the different types of numericals given as per power of a lens. Fine. Hope you have understood it. Please practice hard. Thank you very much.